I'm going to introduce a novel scrolling technique, and the key idea of this technique is that actually we used the model of human attention to optimize the design of this technique. So actually it was first started from our creative solution to some existing problems of scrolling technique. But after that, we used to derive the model to understand the situation and optimize the performance of that technique. So it's called Spotlights, and this is the final system, and I will explain. So there are four chapters in this talk, and first the motivation. I will explain about the motivation to get to the initial idea of Spotlights, and then how we optimize the design based on the mechanistic model of scroll. And a short part is to explain the implementation of the system, and finally the results from the 3 user studies will be given. So first about the motivation and the idea. The motivation was initially came from the fact that we are not really able to read or get any information from conventional scrolling techniques when the scroll speed is fast. So when you scroll more than 2 pages per second, you are in trouble. And there are many reasons. First, when you scroll fast, too many objects are now competing for the visual selection. So you have to decide which one to look at. And the motion blur from the fast movement of text and figures makes the situation worse. And finally, the exposure time for an object is too short, and there is a cognitive phenomenon called attentional blink, that the second of 2 targets cannot be detected or identified when it appears close in time. So that's the problem of this conventional scrolling technique. So in this study, we want to solve each of problems by using selected, which selects important objects from the previous pages. And those selected objects will be remain static to avoid motion blur. And finally, the exposure time of each object will be prolonged or extended, so we can provide enough time to the user to get the gist of important objects. And this is the final form of Spotlights. It uses selected and static overlays, transparent overlays, when you scroll down the document, so you can get enough time, get enough performance for the visual selection. But there is a question still remains here. The first one is about which object should be chosen from the previous pages, and how many objects do we need to choose, and how long they should be extended after the view changes. So to answer these questions, the key idea is that we use this kind of model-based optimization to solve the problems. And before starting this research, actually our hypothesis was that this kind of overlays, transparent overlays, will not affect the performance of conventional normal scrolling technique, but it will improve almost everything after the 2 pages per second, because actually we are not getting anything from current status of scrolling technique. So actually there is a lot of room to fill with Spotlights, and from our user study, the hypothesis was proved to be correct. So I will explain about the optimization part. So first, we imagine a specific context of scroll with user. Let's assume that we have n important object per page, and the current scroll speed of user is p pages per second. And due to our overlaying technique, the exposure time of each object will be extended by the value of e. And here the e value, it represents the amount of temporal extension of the users. So we have more exposure time here. And from this context of scrolling, there is a time per object, time allowed per object can be calculated like this, which is adding the extended exposure time e to the original exposure time of object determined from the scroll speed. And there is also space allowed per each of objects, which can be also calculated like this. So if you increase the exposure time of each object, there will be more object in the current viewer, so it decreases the space per object. And from these two resources, time and the space per object, our attentional performance will be determined. So when we explore more this model of scroll, we found that there is a fundamental trade-off between temporal and spatial resources of objects. When we increase the exposure time, the temporal resource will increase, but the spatial resource will be decrease. So when we multiply those two quantities, we always get the same amount of resources, which is displayed in the red line. So actually, we have trade-off. If we increase the exposure time, we have less space for the object, so we have to decide the best exposure time. And the basic idea here is that we are now located at the one extreme of the scroll. So the temporal resource is now too limited when compared to the spatial resources. So the basic idea of the optimization is to increase the E gradually until there is no more gain from the attention. And this optimization rule can be expressed as an algorithm like this. And based on this rule, we conducted a calibration study that tries to find the best exposure time of overlays. So in this calibration study, the design is optimized from a user study. So we assume 1 or 2 important objects per page and 10 pages per second of scrolling speed, which is the average between our typical range of scroll. And the initial value of exposure time was set as 500 milliseconds, which is to avoid the attentional blink problem. And it is increased gradually until we get no more gain from the attention. And here the attentional performance of user was measured from the eye gaze of user on each of objects. And we have conducted with 4 participants and 2 different types of objects, graphical and textual objects. And the eye trackers measure the amount of eye gaze on the user on the objects. So from the result, we have found that we need 1.5 seconds of exposure time for textual objects and 1.25 seconds of exposure time for the figures. And actually, there was no effect of number of objects on the gaze performance, which means that now only 1 object per page is fully using the attention performance of user. So we are now ready for the questions: how many objects we have to choose, and how long should they be extended. So I implemented the final system based on this calibration study result. I choose 1 object per page, and I used 1.5 seconds of exposure time for the textual and 1.25 seconds of exposure time for the figure objects. And the system has a preprocessor which converts the PDF file to images, and there is also an object parser which extracts the headings and figures on each pages. And during the scroll, those selected objects are displayed on the current viewer through the overlay controller. And in the object parser, I used a horizontal filter to blur everything in the document, and I used blob detector to choose each of lines, extract each of lines from the document. And based on the height of that blob, I can determine which one is heading and which one is figures. And depending on the aspect ratio of the object, we can also define which one is text or which one is figure. So from this parser, I choose only 1 important object from all pages. Okay. And this is the overlay controller. And one thing I have to note here is that the system uses the same normal scroll technique when the scroll speed is lower than 2 pages per second. So when you scroll slower, it's just normal scroll technique. But if you scroll faster than the 2 pages per second, it becomes spotlights. And to avoid possible confliction between overlays, the selected objects are stacked from the top of the pages. And there is also a function called click and go, and you can directly access the page containing the overlay by clicking on it. So this helps you to reduce the effort to go back to the important objects to read for the text. And this is the final system. So as you can see, there is a spotlight object, and you can click to go there. So if you find something interesting, you can go there to read more. So I have done 3 user studies. Actually, from those studies, we are trying to measure the performance of spotlights in many broad perspectives, like free recall, or dynamics of the scroll, or comprehension performance of the scroll, and about the performance of lookup tasks. And the important idea here is that we didn't control the scroll speed of user during the user study. This means that we have maximized the amount of ecological validity for each of tasks. And however, we still limited the time to be short, so they should be used their reading as a skim. They should be skim read the document with time pressure. And to our knowledge, this is the first study to measure the scrolling performance so broadly, so maybe many people can cite this. So in the first study, we tested 3 recall performance of participants. We used 6 books with many pages, like over 300 pages, and only 90 seconds were given to read the document. And we have measured the self-reported comprehension score and the dynamics of eye gaze of participants. And from the result, we have found that the participants were express more confidence in their skim reading when using spotlights. And from the kinematics of the scrolling pattern, we have found that the participants have scrolled faster with spotlights, and they also have used more backward scrolling than the normal scroll. And this shows that actually they have spotted more important objects from spotlights, and they can go back to the object to read it further. So I want to emphasize this point that spotlights is a very highly dynamic technique rather than passive consumption of information, but you can find important objects and you can go back to the pages and you can do many dynamic way of interaction. And from the pattern of eye gaze, it also shows that spotlights is much more active way of reading papers. And in the second study, we also tested with long documents, but we gave more longer time, about several minutes to read it. And from 16 participants, we have tested 2 books with different difficulty of level. The first book was about the introduction to the HCI, which is university level book, and the other one is about engineering at the level of high school. And 2 dependent measures were used: multiple choice comprehensions measurement and NASA TLX workload. And the results show that, especially for the difficult questions, spotlights increase the score when reading with HCI book. So spotlights is good for reading difficult books. And also for the NASA TLX measures, there was no difference. This means that it does not increase any workload of reading than the normal scroll. And from the pattern of their scrolling, I think this is the most interesting part of this study. But as you can see, the books that are predictable to users, like engineering book, which is much more easier than HCI book, they tend to rely on more normal scrolling. So they read more active with spotlights when reading with difficult book like HCI book. That's why it increased the performance especially for the HCI book. And final user study is the lookup task. You have to find a figure given by the experiment. And I used 20 Kai-Fu papers connected in one PDF. And This is the experimental screen. So in the left side, there is a document, so you have to scroll down. And there is right side, you have the target figure you have to find from the spotlight. Yeah. So the result, twice better with the spotlights. It's much more easier to find figures using spotlights. So conclusion, spotlights is good for every measures or similar to the conventional scroll technique. And this is the first study to measure the skim reading performance so broadly. And I think this can be used to different applications, like when Facebook or Twitter, they want to expose more advertisement, but when you scroll fast, actually you don't get any advertisement, so it can be also used in that kind of bad applications. Yeah. Thanks. Yeah. Any questions?
Michael from Hong Kong Polytechnic University. And thank you, very interesting work.
Thank you.
Could you comment a little bit, what if your system apply on small screen devices such as tablet or cell phone or even the smartwatch? How would it be useful for it? To searching information?
Yeah, that's a good question. And you know, the scroll context is really different from this kind of PDF viewer and a small smartwatch or smartphone. So actually, we didn't test anything about the kind of different devices. But I think the scroll speed is much slower in smaller devices. Your finger movement velocity is much more limited. In that case, maybe the problem is less than this PDF viewer. But so basically we are assuming that we are reading a very long document in a very short time, so it's much more like for skim reading performance.
All right. Okay.
Yeah. Thank you.
Hi, Dimitar from ETH Zurich. Very interesting work. I was wondering, do you have any comments on how your approach could be applied to two-dimensional surfaces and
Oh yeah, that's a good question. And yeah, maybe it can be also used in two-dimensional or three-dimensional ways, but you have to decide what is the problem now. So in this kind of one-dimensional scrolling, the problem is really clear, but in different, if you have many other dimensions, maybe the attentional blink problem will be different from that kind of, you know. Yeah, so it's good, interesting future work. Yeah.
Thank you.
Yeah.
Jeffrey Ho from City University of Hong Kong.
Yeah.
I'm wondering, in your user studies, did you give them introductions or actually basic training about your spotlight features, or you just let them to discover the feature?
Yeah, actually we let them practice our system, and we also encourage to use our system when it's possible, because you know it's very it's not a fair game with normal scroll. They always use normal scroll, but this is really unfamiliar to them. So we try to maximize the performance of our system.
Okay,
yeah.
Thank you.
Hi, Vidya Navalpakam from Google.
Yeah.
Very interesting work.
Thank you.
My question was more about, I can imagine that a spotlight-based scrolling technique could be helpful to the user or detrimental, depending on what you select as a spotlight. So could you tell us a little more about this?
It's a very important question. Actually, I'm now only selecting based on the size of the blob and the saliency of the shape. But it can be also useful if you can select the object based on its context. So actually, it has much more future work, many future work based on that kind of direction. Yeah, thank you.
And also, I'm eager to know how this affects or changes the user's natural scrolling behavior.
Yeah, actually, we need to test with longer time of study, because I think it can completely change the way how we perceive the information from the document. Yeah.
Very nice start.
Thank you. Yeah.
So let's thank our speaker final time. And if you haven't had enough of eye gaze and eye gaze applications, there's another session in this room after the break.